All right, let's talk about compound interest. Let's talk about it in the context of saving money for retirement. So Diane borrows $4,500, and well, you know what? Here, let me just explain this like this. Okay, so let's say that we at year 0 we have $100. Okay, so that's our year, and that's our money. Okay, we'll get back to the 4,500 here. And we have a 10% interest rate. That's pretty high, but it makes the calculations a lot easier for me to do. So that means after 1 year, we're going to have our original $100 plus 10%. Notice I've got the decimal point of $100, which is $110. Okay. Now, at year 2, interest is compounded again, or whoever's holding our money, they calculate how much extra money we should get because they were allowed to hang on to our money. And so we get that original 110, not 100, but that last 110 there. And we're going to add 10% onto that. Okay. And then another year comes, another year goes, and we have $121 that we are now calculating interest off of, and 10% off of that 121. And that gives us $133.10. Okay, so that's how compound interest works. And it's an exponential function, exponential growth function. The more time you leave it there, your money there, not only do you get more money, but it grows faster and faster. Okay. Notice, let me change colors here. We went up $10. Okay. Then we went up $11. Then we went up $12.10. So the amount that we get for interest, it's bigger each time than the time before. But it gets even better if you're saving for retirement. Notice those numbers in red, at least I think they're red. I'm colorblind. Not only do they get bigger, but they get bigger faster and faster. Okay. So, you going from 10 to 11, that's an increase of $1. From 11 to $12.10, that's an increase of $1.10. And so, if you've got a lot of money invested, or you're doing it for a long time, or both, that really starts to work in your favor and really add up. Okay. But that's how compound interest works. Okay. So suppose Diane borrows $4,500. Okay. So she's borrowing money. So when she pays it back, so this is interest against her. It's not growing in her favor. It's growing in the lender's favor. Okay. At an interest rate of 9% compounded each year. Assume that no payments are made on the loan, following the instructions below. Don't do any rounding. All right. Find the amount owed at the end of 1 year. All right. So that'll be her $4,500 plus 9% of $4,500. Okay. Which is $4,905 total. So she borrowed $4,500. She now owes that plus another $405. So after 1 year, she already has $405 of interest. Ouch. Okay, well, it is 9%. Oh, well, maybe it was really important. Okay, what about after 2 years? After 2 years, well, it'll be the $4,905 plus 9% of $4,905. Okay, which will be $5,346.45. So the longer she borrows this money, the longer it takes her to pay it back, the more she's going to owe, but the faster the interest is going to grow. So that could be a problem for her. So she has to really keep track of that. Now, another way of doing this, just in case you care, is to say 1.09 times 4,500 or 1.09 times 4,905. Okay, so instead of saying, hey, I want the original 100% plus 9% of that, you could just say, I want 109% of that. And it's the same thing. You can double check it. Okay. All right, so a laptop computer is bought for $1,400. Dang, I've never spent that much. After each year, the resale value goes down. What a surprise. By 35%. So you lose about a third of the value every year, whatever the value was at the beginning of the year. What will the resale value be after 3 years? Well, I can kind of wing it. If we lose, let's see, a third of 1,400 is going to be about $450. So after 1 year, you know what? Let me go on my calculator and do it that way because it's fun. So after 1 year, she loses or he loses, whoever, $450. Now we're down to $950. Then we lose about another third for the second year, and a third of that is going to be about I don't know, 315. Whoops. Okay. And then for the third year, you lose about a third of that. A third of 635 is going to be about 212. And it's going to be around $423 is roughly how much the laptop is going to be worth after 3 years. Okay. So that's not the way they want you to do it, but that's okay. So let's do it in more more accurate way. That was just sort of winging it. All right, so use a calculator to provide, okay, blah, blah, blah. All right, so let's make a function because we got to do that eventually. So the starting value is always the number that goes out front for an exponential function. And then the base of the exponent, t for time, the base of the exponent is going to tell you what percent you end up with. Okay, so if you decrease, if the laptop decreases by 35%, what percent of the value do you retain? Well, 100% minus 35% is 65%. So you maintain 65%. All right, cool. So after 3 years, we would want to say, all right, well, what's y of 3? Well, I don't know, but I know I've estimated. Okay, so let's go check that out on the calculator and see if we can't, see what's going on. All right, so I've got my function. Let's go to the table. Whoa, okay, let's go to second window and sort of jump to a starting value of like 0. Okay. And after 3 years, $384.48 is the value. We estimated more than that, but it was kind of a rough estimate. Whoops. We estimated $423. Okay. I mean, yeah, we were certainly heading in the right direction, but I also knew that that was, doing it with the calculator was going to be more accurate. All right, so now let's do something else that involves compound interest. Suppose that $2,000 is invested at a rate of 3.1% compounded annually, assuming that no withdrawals are made, because if there are withdrawals, then that makes the problem more complicated. Find the total amount after 5 years. Okay, don't do any intermediate computations, or don't round them off, I should say. All right, so we start off with 2,000. Okay, so that's our number out front because that's our starting amount. And interest is 3.1%, which is 0.031. Now, if I just go 0.031 to the t power, that's not really going to work. Okay, you can plug this function in your calculator. Notice as x gets bigger, y is getting smaller. The total amount of money is getting smaller, but we're investing money. It's supposed to grow. All right, so what's the problem? We know we need the 0.031. That helps govern how fast things are growing. But remember, whatever number is in here in the function, that tells you what percent of the money you end up with. Well, this says you're only going to end up with 3.1%. So what we need to do is say the original 100%, the $2,000, plus 3.1% of that. Okay. You can write it like that, or you can write it, of course, like that. Same thing, obviously. All right, so the question is, what is, how much money are we going to have in 5 years? Well, it's not going to be a real big increase, but it will be more, of course. So I'm going to go over here. I'm going to say $2,000 times 1.031 raised to the 5 years. And we end up with $2,329.83. So not a lot of increase, but if we take that and subtract from it whatever we started with, we have $329.83 of interest. Okay, that's the amount of interest that we've got. All right, so here's another one. A laptop computer is bought for $4,100. Good heavens. I just bought one for like $400. I thought I was, well, for me, that's a lot. Each year, its value is 80% of its value the year before. Now, if it said each year its value was 100%, then that would mean, the original amount. It's the price, the value is not changing, but that's not the way it works. So you're losing 20% each year because you're retaining 80%. After how many years will the laptop computer be worth $1,000 or less? Well, we can make a function. It starts off with a value of 4,100, and every year you end up with 80% of the value from before. So I'll put 0.8. And the question is, when will it have a value of $1,000? Okay, so what do I do with the 1,000? Well, I don't plug it in for t because t is time and 1,000 is dollars. So, but we do know that the y, that tells us the ending amount, the ending value. So that's where we're going to plug it in, right there. Okay. So we've got that. And of course, we could do that by get some help with the calculator, which I will. But first, I'm going to say divide both sides by 4,100. I can cancel the zeros and blah, blah, blah. And I get 10 over 41 equals 0.8 to the t. And, well, we're going to cover this. Actually, I think we already did. Yeah, we're going to cover how to solve this, but you should have seen it in the past, so I'll just do it anyway. We can convert this to log form and get log base 0.8 of 10/41 equals t. Right. And let's see what we get on the old calculator. So I'll go alpha window 5.8 10 over 41. And it looks like it's going to take about 6 1/3 years, 6.32 years. That's like 6 years, 4 months, 6 1/3 years. Yeah. Now, another way you could have done it would be to say, all right, let's plug in the function. Let's see, times 0.8 raised x. Yeah. Okay. And then we could go to the table. Or actually, you know what? Let's not worry about the table. Let's go. Let's just say, okay, well, I've got this equation. Let me change colors here. I've got this equation right about here. Okay. Any equation you can solve by plugging in both sides of the equation. So there's the other, whoops. There's the other side of the equation. And then just see where they intersect. Okay. All right. Now, so if I go to the graph, well, let's see. First of all, let's get rid of all that stuff because it's really in the way. Well, in this problem, our x, that represents t, time. So we don't need to go negative 10 years before the situation starts. Going out to 10 years, that's probably far enough. We know the answer is 6 1/3 years. And y stands for the amount of money. Well, negative $10 to $10 is not really going to be helpful. In fact, we know that we're not going to go below $1,000 in this experiment, and we are starting off at 4,100. So if we take a look at the graph, we see the intersection point right there. It's a second, trace 5, 3 enters, and there it is again, the exact same number.